In the United States, the standard for running CI-rated cables in outdoor direct buried applications is detailed in FPL-CI, the National Electrical Code, specifically Article 300.5. This article allows for the use of CI cables without conduits or raceways when buried at least 24 inches deep and protected from mechanical damage. Now, addressing overhead notification circuits in cable trays outdoors, armored FPL-CI rated cable is not necessarily required, provided that certain conditions are met. Firstly, the cable tray itself must be listed for outdoor use. Secondly, the cable tray must be properly supported and secured. Thirdly, the cable tray must not be exposed to physical damage or environmental hazards. The standard method of installation for outdoor notification circuits and cable trays involves using an unarmored FPL-CI rated cable that meets the requirements outlined in NEC Article 760.179 concerning conductors and cable trays. In addition, the cable tray must adhere to NEC Article 392.5, ensuring it is listed for use in wet or dry locations, ventilated to prevent the accumulation of flammable gases or vapors, and supported and secured to prevent damage. Let's delve deeper into the specifics of these NEC articles. NEC Article 300.5 provides comprehensive guidelines for underground installations. It outlines the minimum burial depths for various types of cables and raceways, as well as requirements for protection against physical damage. The 24-inch depth mentioned earlier is a general guideline, but the specific depth may vary depending on the voltage of the cable and the type of installation. It's crucial to consult the specific requirements in Table 300.5 to ensure compliance. Furthermore, Article 300.5 addresses the need for protecting cables from physical damage. This can be achieved through various methods, such as using rigid metal conduit, intermediate metal conduit, or reinforced thermosetting resin conduit. However, for CI cables, direct burial is permitted without these additional protective measures, provided the minimum burial depth is met. Now, let's turn our attention to NEC Article 760.179. This section specifically addresses conductors and cable trays used for fire alarm systems. It outlines the types of cables that are permitted in cable trays, as well as requirements for support and securement. The key requirement here is that the FPL-CI cable must be listed for use in cable trays. This listing ensures that the cable has been tested and found to be suitable for the specific environment and conditions in which it will be installed. In addition to the cable requirements, NEC Article 392.5 outlines the requirements for the cable tray itself. As mentioned earlier, the cable tray must be listed for use in wet or dry locations. This listing ensures that the cable tray is constructed of materials that are resistant to corrosion and degradation from exposure to the element. Furthermore, the cable tray must be ventilated to prevent the accumulation of flammable gases or vapors. This is particularly important in industrial settings where flammable substances may be present. The ventilation helps to dissipate any gases or vapors that may accumulate within the cable tray, reducing the risk of explosion. Finally, the cable tray must be supported and secured to prevent damage. This includes ensuring that the cable tray is properly anchored to the building structure and that the cables within the tray are adequately supported. Proper support and securement prevent the cable tray from sagging or collapsing under the weight of the cables, and also prevent the cables from being damaged by vibration or movement. It is essential to carefully consider the specific requirements of each NEC article and to consult with a qualified electrical engineer or inspector to ensure compliance. Understanding the nuances of these codes is critical for ensuring the safety and reliability of fire alarm systems in industrial installations. In summary, when running CI-rated cables and outdoor direct buried applications, adhere to FPL-CI NEC Article 300.5, ensuring a minimum burial depth of 24 inches and protection from mechanical damage. For overhead notification circuits in cable trays, use an armored FPL-CI rated cable meeting NEC Article 760.179 with a cable tray listed for outdoor use, properly supported and secured, and meeting NEC Article 392.5 requirements for ventilation and environmental suitability. Remember to always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. These codes are subject to change, and it is your responsibility to ensure that your installations comply with the latest standards. Additionally, always use qualified personnel for the installation and maintenance of fire alarm systems. These systems are critical for life safety, and it is essential to ensure that they are installed and maintained correctly. Failure to comply with these requirements can result in serious consequences, including fines, penalties, and even legal action. Therefore, it is always best to err on the side of caution and to seek professional guidance when in doubt. Let's consider some additional factors that may influence the selection and installation of CI-rated cables and cable trays. The specific type of CI cable required will depend on the voltage of the circuit and the environmental conditions in which it will be installed. For example, if the cable will be exposed to corrosive chemicals, a cable with a chemical-resistant jacket may be required. Similarly, if the cable will be exposed to extreme temperatures, a cable with a high temperature rating may be necessary. The size of the cable tray will also depend on the number and size of the cables that will be installed in it. It is important to select a cable tray that is large enough to accommodate all of the cables without overcrowding them. Overcrowding can lead to overheating and reduce cable life. In addition to the NEC requirements, there may be other applicable codes and standards that must be followed. For example, some jurisdictions may have local codes that are more stringent than the NEC. It is important to check with the local authorities to ensure that your installation complies with all applicable codes and standards. The proper grounding and bonding of electrical systems is crucial for safety and performance. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Bonding connects all of the metal parts of the electrical system together, which helps to equalize voltage and reduce the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding in Article 250. It is important to follow these requirements carefully to ensure the safety of the electrical system. Regular inspection and maintenance of fire alarm systems is essential for ensuring their continued reliability. Inspection should be performed by qualified personnel at least annually and more frequently if necessary. During inspections, all components of the system should be checked for damage or wear, and any necessary repairs or replacements should be made. Maintenance should include cleaning and lubricating components, tightening connections, and testing the system to ensure that it is functioning properly. By following these guidelines, you can help to ensure the safety and reliability of fire alarm systems in industrial installations. Remember that these systems are critical for life safety, and it is essential to take all necessary precautions to protect them. Also consider the ambient temperature. Electrical components and cables have temperature ratings. Ensure that the selected cables and components are suitable for the expected temperature range in the installation environment. High temperatures can degrade insulation and reduce the lifespan of cables. Low temperatures can make cables brittle and susceptible to damage. Ensure the cable jacket material is compatible with the environment. Some cable jackets are resistant to chemicals, oils, or UV radiation. Select a cable jacket that is suitable for the specific environmental conditions of the installation. Furthermore, consider the ampacity of the cables. The ampacity of a cable is the maximum amount of current that it can safely carry. Ensure that the cables are sized appropriately for the load that they will be carrying. Using undersized cables can lead to overheating and fire. Also, remember to use proper cable support methods. Cables should be properly supported to prevent sagging and strain. Use cable ties, clamps, or other approved methods to support the cables at regular intervals. Proper cable support helps to prevent damage to the cables and ensures that they will last for many years. Finally, documentation is key. Maintain detailed records of all cable installations, including cable types, sizes, ampacities, and routing information. This documentation will be invaluable for future maintenance and troubleshooting. Also, consider surge protection. Install surge protection devices to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, and surge protection devices can help to prevent this damage. Surge protection devices should be installed at the service entrance and at any other points where sensitive equipment is connected to the electrical system. Think about future expansion. When designing the electrical system, consider the possibility of future expansion. It is often easier and less expensive to install extra capacity during the initial installation than it is to add it later. Consider the possibility of adding more circuits, more outlets, or more equipment in the future. Choose appropriately sized conduits and cable trays to accommodate future expansion. Consider energy efficiency. Use energy-efficient lighting, motors, and other equipment to reduce energy consumption. Energy-efficient equipment can save money on electricity bills and reduce the environmental impact of the facility. LED lighting is a good option for energy-efficient lighting. High-efficiency motors can also save a significant amount of energy. Finally, remember safety first. Always follow all applicable safety codes and regulations when working on electrical systems. Wear appropriate personal protective equipment such as safety glasses, gloves, and hearing protection. Work on to energized circuits whenever possible. If you must work on energized circuits, use appropriate insulated tools and equipment. Never work alone. Always have another person present to assist you in case of an emergency. In addition, consider the effects of electromagnetic interference, also called EMI. EMI can disrupt the operation of electronic equipment. Shielded cables can be used to reduce EMI. Also, locate sensitive equipment away from sources of EMI, such as motors and transformers. Consider vibration. Vibration can damage electrical equipment and cables. Use vibration isolation mounts to reduce vibration. Also, use flexible conduit to connect equipment that is subject to vibration. Think about accessibility. Ensure that electrical equipment is accessible for maintenance and repair. Provide adequate clearance around equipment. Install access panels where necessary. Accessibility is important for both safety and efficiency. Consider the use of uninterruptible power supplies, commonly referred to as UPS. UPS provide backup power in the event of a power outage. UPS can be used to protect critical equipment, such as computers and servers. UPS are available in a variety of sizes and configurations. Additionally, consider the life cycle cost of electrical equipment. The life cycle cost includes the initial cost of the equipment, as well as the cost of operation, maintenance, and disposal. Choose equipment that has a low life cycle cost. Energy-efficient equipment typically has a lower life cycle cost than less efficient equipment, even though it may have a higher initial cost. Also, think about the maintainability of electrical equipment. Choose equipment that is easy to maintain and repair. Select equipment that has readily available replacement parts. Regular maintenance can extend the life of electrical equipment and reduce the risk of failure. Remember to train personnel. Provide adequate training to personnel who will be operating and maintaining the electrical system. Training should cover safety procedures, operating procedures, and maintenance procedures. Well-trained personnel are essential for the safe and efficient operation of the electrical system. Always consider the specific requirements of the application when selecting and installing electrical equipment. There is no one-size-fits-all solution. Carefully evaluate the needs of the application and choose equipment that is appropriate for those needs. Do not hesitate to consult with qualified professionals for assistance. Qualified professionals can provide valuable guidance on the selection, installation, and maintenance of electrical equipment. Consulting with professionals can help to ensure that the electrical system is safe, reliable, and efficient. Furthermore, remember to regularly review and update the electrical system. Electrical systems should be reviewed and updated periodically to ensure that they are still meeting the needs of the facility. Changes in the facility or in the electrical codes may require modifications to the electrical system. Regular reviews and updates can help to prevent problems and ensure that the electrical system remains safe and reliable. Always prioritize safety when working with electricity. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Follow all applicable safety codes and regulations. Work on de-energized circuits whenever possible. Use appropriate personal protective equipment. Never work alone. In conclusion, by following these guidelines, you can help to ensure that the electrical system is safe, reliable, and efficient. Remember to prioritize safety, consult with qualified professionals, and regularly review and update the system. The information presented here is intended for educational purposes only and should not be considered as a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before making any decisions about electrical installations.